Coming up, an Orlando scientist could be on the verge of revolutionizing the way computer sensors, solar cells, and many other items are made.
If IZEA really has this and it really works, this is a huge technical leap and business opportunity.
And can drones show the way to a sustainable future?
This planet continues to have more people on it, so we have to do a better job on the land we have and get more out of the resources we put in, get higher yields to feed more people.
Exploring the frontiers of science. Probing cutting-edge technologies. Seeking answers to the big questions. Welcome to SciTech Central. Modern life depends on computer chips, solar cells, miniature sensors, and many other items made with very thin films of specialized materials. A Central Florida scientist is developing a new technology that could radically change the way thin films are made. Thin film deposition is a mature technology. It's been around for at least 200 years. One common application is electroplating, which is used to make everything from silverware to chrome auto parts. Advanced applications, first developed in the 1960s, can apply extremely thin, extremely precise layers to create computer microchips, advanced sensors, and solar cells. It's a manufacturing technology that has changed the world. But it has major limitations. It must be done in a vacuum, and often involves powerful electrical charges and high temperatures. It's a difficult and expensive process. Dr. IZEA Aladeji has developed a technique that could revolutionize the way at least some thin films are created.
The machine behind me is called VP Speed, as Vapor Phase Speed System. It is one of our tools that we use in drawing film on substrate. As you can see, we just have one single nozzle, and that single nozzle is scanning the wafer in order to grow the film just across the wafer. Then it's repeating itself again.
Dr. Aladeji's invention is not merely a new machine. It's an entirely new way of creating very thin films.
This process is a two-part process. It's also about the chemistry. So the chemistry is patented, and the tool itself is patented. Our chemistry is the unique thing that's allowing us to do some of the things we are doing, not just the tool. The chemistry is using water as a solvent instead of vacuum. That is very expensive, or instead of organic solvent that are equally expensive compared to just simply water. The complete process itself is about the chemistry formulation on one hand, and the process steps that one can take that chemistry through to get a film. And then at the last stage is now the tool. So it is a combination of all these that is really making the process itself unique.
And the process doesn't require a vacuum. It can be done under normal laboratory conditions, so the complexity, and thus the cost, is significantly reduced.
The big vacuum systems are extremely expensive. IZEA's system is a tenth the cost, maybe even better. And then the ability to make large quantities in large surfaces, something else that's hard to do in a vacuum.
Craig Nelson is an engineer with experience in thin film deposition. He immediately recognized the enormous potential of Dr. Aladeji's invention.
It was remarkable to me, having come out of a metal organic chemical vapor deposition company, which is all high vacuum, very expensive equipment, a lot of safety issues to create device structures, to IZEA's lab, which was the other end of the spectrum in elegant simplicity. And he was making thin films with very inexpensive tools. So I thought, if IZEA really has this and it really works, this is a huge technical leap and business opportunity.
Nelson is working with Dr. Aladeji to commercialize the process.
That's been my role on very much of the engineering and process control side, which marries really great with IZEA's molecular, chemical, and ions. So we have the ions in one partner and the nuts and bolts in the other partner.
Richard Fox is handling the business side of the venture.
I've been working with IZEA from the beginning in visualizing where the company can go. What business should it be in? Who should the customers be? What's the strategy of the business?
The men have created a company called Sysum Thin Films. Their goal is to transform Dr. Aladeji's successful laboratory experiment into a full-fledged business. If they're successful, the process could potentially make countless products cheaper and easier to manufacture.
It could be used in making lithium-ion battery. It could be used in making solar cells. It could be used in making sensors. And it could be used in making all other different kind of film that could be used in some other application that I cannot even begin to list. And as a result, the market that we can operate in are so numerous. So it's a question of finding the right customers and giving them what they want.
In entrepreneurial circles, finding the right customers is called customer discovery. It's the key to Sysum's future.
By doing customer discovery, you find out where they are. And we believe that between all of the different aspects of our small business, which include services to provide thin films of special specifications, to provide the equipment, the process, and the chemicals as a bundled package, to supplant the old way of making things with vacuum tools, with a streamlined, low toxicity, much more green materials and process, and lower cost of operation and lower cost of capex, that Sysum is going to grow and prosper.
In addition to his groundbreaking work on thin films, Dr. Aladeji is developing inexpensive techniques to provide electricity to rural Nigerians. Correspondent Steve Mort sat down with him to talk about one of these projects.
So first of all, we're talking about your work in Nigeria. What is the problem you're trying to solve? What's the situation with power in Nigeria?
Well, Nigeria has 170 million people. And currently, Nigeria is generating only 5,000 megawatts of electricity. And if I base it on the energy requirement of the United Nations, the country needs to be generating a minimum of 40,000 megawatts of electricity.
So you've come up with what you hope is a solution
Yeah.
to this problem. Mm-hmm. And that involves biomass.
Yes.
So tell me about this technology. You found a plant that's very abundant in Nigeria, and how do you hope that's going to help?
Generally, when people talk about biomass as a source of, as a feedstock for power generation, what goes into the mind of everybody is how you're going to sustain it. The beauty of this idea is that this plant is a wild growing plant. There's no need to have a specific farm for it. I mean, the tree, actually, I believe that tree can probably live for more than 100 years. But on a yearly basis, it produces a fruit, and that fruit dries out. I mean, when it dries, it's woody, and it falls down, and then when the rain comes, and it just goes to waste.
Yeah.
So the idea is to, on a yearly basis, just pick up those fruits without destroying the tree itself, and use those fruits, transform them into a biomass pellet, and use that to power the biomass generator.
But with your power plant, you can only generate a relatively small amount of electricity.
Yes.
That's not going to solve Nigeria's
That's
power
not gonna
problems,
solve-
right? So how do you do that?
So what we are talking about, what we are doing right now is that we are actually actively discussing with one of the regional distribution company. And the hope is that once we sign a power purchase agreement, is to set up a 20 megawatt power plant. Our issue right now is actually about how do we raise the fund needed to set up our first main or major power system.
Dr. Isaiah Aladeji, thanks so much.
Thank you very much.
From the Seattle Space Needle to New York's George Washington Bridge, amateur drones have everyone buzzing about these high-tech aerial vehicles. Reporter Sophia Cruz was in America's heartland, where researchers and farmers are using drones to help figure out the future of agriculture.
Well, it used to be in agriculture, it was all hands-on. You drove the tractors, you you manually change things, but now computers have taken a lot of the tedious stuff out.
Jeff Sandburn is a corn, wheat, and soybean farmer in Portland, Michigan, and his job has changed a lot over the years as innovation in agricultural technology has increased at a breakneck pace. And while not all farmers are eager to adopt this new technology, Jeff is.
We only have so much land that can grow crops, productive crops, and this planet continues to have more people on it. So we have to do a better job on the land we have and get more out of the resources we put in, get higher yields to feed more people.
But what if there was a way to increase crop yield and farmers' profitability while decreasing over-fertilization and water waste? At Michigan State University, a team of researchers is piloting a project that will do just that.
The drone, we call it the giant mozzie because it's like mozzie is a nickname for mosquitoes in Australia. I mean, I used to work in Australia. It's very, it sounds like a mosquito, but I use it to fly over farmers' field and detect changes in plant performances.
Bruno Basso, an Italian native, has relocated to America's heartland to pilot a new research project using unmanned aerial vehicles, otherwise known as drones.
When a drone flies like this specific type flies over a field, it detects information about reflectance of light from the plant. So you are able to get an information for a very large area at a fine scale.
Commercial drones have been used by farmers for years to provide a bird's eye view of their crops, and it's estimated that 90% of all drone use by the year 2025 will be in agriculture. But Bruno's drone does much more than take pretty pictures from above. This drone is able to survey large sections of land down to the millimeter, generating detailed maps which lend farmers valuable insight into their fields.
Everything that I do in a field costs me money, whether it's the seed I buy, the fertilizer I use, the chemicals that are applied. If I can get the most efficient use out of that resource, whether it's seed, fertilizer, which fertilizer is very energy intensive, I want to grow the most crop I can out of that given unit of fertilizer.
But increasing the amount of fertilizer does not necessarily mean a farmer will see an increase in the amount of crops he is able to produce. And for Bruno, a uniform application of fertilizer is simply a waste.
So the uniform application that normally a farmer does, by definition, he overestimates this input in one area and he underestimates inputs in the other area. And so that's the important. One size fits all is not the case in agriculture because there is a lot of variability. So in the end, what does the drone do? Tells us about that variability.
Understanding field variability is one part of the puzzle, but for all that information to be useful, a farmer has to know what practical measures to take. That's why Bruno is developing easy-to-use software that not only breaks the information down, it actually creates a predictive model that allows a farmer to digitally test out a change in their farming practices without any risk to their yield. The implications of Bruno's research are clear. Smart advancements in agricultural technology could be the key to increasing farmers' profitability, decreasing the environmental impact, and increasing food production to support an ever-growing global population.
Want to satisfy your scientific curiosity and be on TV at the same time? Send us a video question for our Ask a Scientist feature. Here's an example.
My name is Kelly. I'm from Orlando, Florida. I know coral reefs are important to the health of the oceans, but I would like to know why.
Go to our Facebook page to learn how to submit your video. Scientists who study plants can't always get into the field to collect data. Preserved specimens of plants are crucial to their work, and the New York Botanical Society has one of the largest collections in the world.
An herbarium is a collection of dried plants for scientific study. So plants have been collected for many, many years, going back to the Middle Ages. Starting out, they were collected mostly for medicinal purposes. We have about 7.3 million specimens, which makes us the 4th largest herbarium among the top 4 in the world. So now we're coming into our cold storage room. This is kept at about 54 degrees, and it's the holding space. When the plant specimens first arrive at the garden, they come in here, right from the field. On this side of the room, all of the specimens are our staff's field collections, and those are waiting to be identified. Sometimes it takes a few months for specimens to be identified. Sometimes it takes 50 years. It depends on whether or not that plant group has a specialist. On this side, all of these plants are already identified, and they're just waiting their turn to go up to the mounting room, where they'll be glued to paper and then eventually filed in the herbarium. So this is the specimen mounting room. All of the plants that come into the New York Botanical Garden each year from all of our many field expeditions eventually end up here. And this is the room where they're turned from field specimens into permanent archives that are meant to be kept indefinitely. What makes it a good specimen is if it shows all the features that are important to see. In the mounting room, we have several people highly skilled in taking these specimens from their newspaper, gluing them onto a piece of paper. We just use a basic Elmer's type of white glue. Sometimes the woody plants aren't completely flat, so they can use glue, but sometimes they also have to stitch down the plant. Sometimes the plant has bits that come off, which have to be put in a little packet, and they also try to make it look attractive as well. So now we're coming into the herbarium. This is the actual archive where the specimens are stored. This is a typical floor. It contains about 2,000 cabinets that are arranged on these movable aisles. The steel cabinets that we have in the herbarium are all specially designed for this purpose. In fact, this is even called the New York Botanical Style herbarium cabinet. Each cabinet has 52 shelves. The plant specimens are put in paper cardboard folders. They're arranged by plant relationships, by their family. Every plant belongs to a family. And they then are also arranged in these outer folders, which are color-coded. Here's a specimen that was collected fairly recently, actually 2001, from the Intermountain West, where we've been focusing a lot of our collecting activity for the past 50 years. Here's a specimen that was collected by Charles Darwin. We don't think of Darwin much as a botanical collector, and in this case, the specimen is actually not even a flowering plant. It's a tiny moss that he collected on the voyage of the Beagle. We also have specimens like Darwin that are very old. Here's one that's even older. Here's a specimen from the Captain Cook voyage, which went around the Cape of Good Hope and Cape Horn in the 1700s. This is a specimen collected from Tierra del Fuego. We also, since the mid-90s, have been creating a virtual herbarium. We've been digitizing the specimens and making them available online so that anyone at any time can consult the herbarium just by coming to our virtual herbarium website and searching. We would just capture an image using a high quality but an instant capture image, and then when we put them online, instead of writing a request wondering what specimens do you have of this plant or that plant, they could simply go online and look and find out. One of the things I really enjoy is taking a walk through the herbarium every day. And as I walk around, I see my staff who are working on projects. I like to walk around and just see science in action.
Widespread access to broadband internet has quickly taken hold throughout much of the U.S., but many isolated rural communities are being left behind. Tamika Weatherspoon reports from Thurman, New York, on how the town hopes to utilize unused TV spectrum, called whitespace, to bring the town into the broadband universe.
Towns like Thurman, nestled inside the Adirondack Park, are hard to reach.
Thurman's very rural. You cannot buy gas in the town of Thurman. You can't buy a gallon of milk in the town of Thurman. It's very community-oriented, very quiet, peaceful town.
Everyone knows everyone, but in a major way, they're disconnected. Much of the town still uses dial-up, or drives to the local town hall Wi-Fi hotspot for internet service.
Without broadband access, little communities like this one aren't going to survive very well. It makes a huge impact on your entire community. Your children can't do their homework assignments, so they're having to choose between sports and getting their homework done, college applications. It affects every aspect of life, how you shop, how you bank, everything. And if it's not something that it's accessible to your community, people aren't going to come or stay in your community.
Like many other New York towns, Thurman is taking initiative, but moving in a direction few have gone before. They're one of the first communities in the country trying to create a residential white space network.
In the Adirondacks, especially in the Adirondack Park, we face a couple of unusual challenges that you don't find elsewhere in the country. For one thing, the Adirondack Park Agency restricts us from building on peaks or ridgelines. So we can't just put a tower on top of some mountain. For another thing, when you do wireless, the existing technologies before the white space technologies would not pass through trees and leaves, which means you could not do wireless networks. So the benefit of the white space is the fact that the signals are much lower frequency and they travel through the trees.
The goal is to transmit high-speed internet to residents using white space, or the unused portions of the analog TV spectrum. It's perfect for rural areas, since they tend to have more open channels than cities. On this day, they're still in the testing phase, determining the best locations to put radios to relay the internet signals across the town.
It's a matter of a relay, bouncing signals from one spot to the next. What we are doing is we are borrowing or renting a space on the fiber from Frontier or Verizon, and we will plug into that. And then we will be extending that and cover a certain radius of houses that will get this. And then within that radius, then we find another spot and we bounce the signal to the next area.
One thing they already have figured out, where to place the heart of the network.
This is the center of Thurman's White Space Project. We're on South Johnsburg Road at the highest point of the road. And along this road is the fiber that we intend to tap into. We have to the right, Frontier's fiber on a pole. We also have Verizon on the very same pole. So we have both carrier diversity and route diversity. Test antenna, base station, it's mounted actually to a tree, so it's up in the leaves of the tree. And from here we hope to cover the road going to the north, going down to the south, and west out to Garnet Lake.
This town pulled together to procure a grant through the statewide Connect New York Broadband Initiative. Those funds cover the cost of testing and constructing a residential network.
There we go.
Other white space experiments in Virginia and California, for example, were conducted using older models.
It's been tested in a few areas of the country. The FCC has been working on approving it for several years and had done so, I believe it was the end of 2011 in December, they finally approved the use of it. The equipment was not available until early this year. So any trials that were done elsewhere in the country were using first generation equipment from a different vendor. So we're now on second generation equipment, which has much higher capacity.
We've had businesses close down because they don't have internet, they can't process credit cards, they can't get online. They've actually had people stop their sale to buy a home here when they found out there was no internet. We're hoping that once we get Thurman up and running and everybody else sees what we were able to do, we feel certain that it'll just take off everywhere.
If testing continues according to plan, they're hoping to begin the building of the actual network during the summer, having everything up and running for residents by early autumn.
That's all for now on SciTech Central. Thanks for watching. Join us next week for more stories from the frontiers of science and technology.